Length L, mass is m, radius is r, length is L. Comparison between linear motion and rotational motion. Now, at one end perpendicular to its length, what is the moment of inertia? What is the radius of gyration? And moment of inertia about a tangent is 7/5. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. Just to have a glimpse of what we have studied in the chapter System of Particles, we understood what was a rigid body, where we told a body whose shape and size does not change under the action of an external force was called to be a rigid body. We studied the concept of moment of inertia, rotational inertia, where we told the opposition offered by a body during its rotational motion is called moment of inertia, which was I equals mr square mathematically. We studied the concept of torque, the parallel axis theorem, the perpendicular axis theorem, and calculated a few problems based on these concepts. If you remember the previous session, I told we need to understand the geometry of the object given, the axis of rotation, so that we can define moment of inertia more precisely. In today's class, I will give you a table which will define the object, the geometry of the object, the axis of rotation, and so on, which will help us to solve problems, especially in entrance exams. So this is the table I am talking about. First is the geometry of the body. The first column gives me what type of object I am considering, the dimension which is considered, axis of rotation, moment of inertia. So the geometry of the body, the dimension considered, axis about which the body is rotating, and finally moment of inertia. This is an additional part where I have also added the radius of gyration, but this is not so significant for us compared to the previous tables. The first body, it is a thin rod. ಯಾವುದು ನಾವು ಫಸ್ಟ್ ಆಬ್ಜೆಕ್ಟ್ ಆಗಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಿದ್ದೀವಿ, ಇಟ್ ಈಸ್ ಅ ಥಿನ್ ರಾಡ್. Dimension, The thin rod will have length L, mass M. So the dimensions I prefer here is the length of the rod, which is L, mass of the rod, which is M. The first axis of rotation is passing through the center of mass perpendicular to its length. Passing through the center of mass perpendicular to the length of the rod. About that axis, the moment of inertia is written as ml square by 12. So, ನೆನಪಿಟ್ಕೊಳ್ಳಿ, moment of inertia of a thin rod which has length L and mass M about an axis passing through the center perpendicular to its length is ml square divided by 12. And the moment of inertia of the same thin rod of length L, mass M, at one end perpendicular to its length, one of the ends perpendicular to its length is ml square by 3. So this is the moment of inertia of the thin rod about its center perpendicular to its length. This is the moment of inertia of a thin rod at one end perpendicular to its length. Next one, the body is a thin circular ring. What is the shape of the body now? Geometry of the body, thin circular ring of mass M. Adu ring ado, circular ring, dimension mass M, passing through its center. ಇದನ್ನ ಯಾವಾಗಲೂ ಕೇಳ್ತಾರೆ, circular ring of mass M. What is the axis passing through the center? Is mr square. This is a familiar object. Thin circular ring. Dimensions, it has mass M, axis of rotation, center, moment of inertia, mr square. Next, the geometry, solid cylinder, cylinder now, dimensions, it has mass M, radius r, length L, mass is M, radius is r, length is L. What is the first axis? Again, passing through the center perpendicular to its length, so its moment of inertia is m r square by 4 plus L square by 12. Moment of inertia of a solid cylinder passing through its center perpendicular to its length, passing through an axis parallel to the length, Moment of inertia is mr square divided by 2. So for a solid cylinder which has an axis passing through the center perpendicular to the length, moment of inertia is given about an axis parallel to its length, mr square divided by 2. And finally, where the geometry is a solid sphere of mass m, radius r, axis about the diameter, moment of inertia 2 by 5 mr square. Usually this is also the moment of inertia of Earth, where Earth is considered to be a solid sphere, and moment of inertia about a tangent is 7 by 5 mr square. So please note here the dimensions thin circular ring and dimensions solid sphere is often considered for calculations. So I have given you a table which illustrates objects of different dimensions, different axis of rotations, where moment of inertia is defined. With respect to that, we also have the radius of gyration. Now, as the last part of discussion, we will compare linear and rotational motion. Comparison between linear motion and rotational motion. Now, physical quantity, displacement. What is its units in linear motion? Meter. What is it called in angular motion? Angular displacement. Units, radian. So in linear motion, displacement has a unit meter. Rotational motion, it is called rotational displacement in a unit theta, which is called radians. Velocity in linear motion, meter per second. It is denoted as omega in rotational motion, where the SI unit is radian per second. Acceleration, linear motion, meter per second square. Rotational motion, angular acceleration, denoted by alpha, which has the unit radian per second square. These are the three equations of motion for linear motion. Comparing, these are the three equations for rotational motion. Transcripting in the form theta, omega, alpha. Comparing it with linear motion, three equations for rotational motion. Momentum in linear motion, mass into velocity. Angular momentum, L, I omega. What is I? moment of inertia, omega, angular velocity. Force, linear motion, mass into acceleration. What do you call force in rotational motion? I was very clear. Torque, which is I alpha. Linear motion alli force anta helidre corresponding to rotational motion, it is torque. Impulse, change of linear momentum. Impulse during rotational motion, change of rotational inertia or angular momentum. So work done, kinetic energy. So we understand here saying that the mass m and linear velocity in the case of linear motion, we have moment of inertia and angular velocity respectively in rotational motion. There is one chapter concept called center of mass, which I will be discussing in detail, not as a part of this chapter. I have kept it aside for discussion. So very clearly today, I have prepared a table, given you an idea for different dimensions, different axes. What is the moment of inertia? What is the radius of gyration? And respectively, a comparison between linear motion and rotational motion. In my next class, we start with mechanical properties of solids. Until then, have a nice time. Thank you.